record. Hey, everybody who's gone, like Quiz Bowl people and Caleb who's sick. We are doing some weird things now. We are skipping from chapter 6 all the way to chapter 10 because they kind of flow together, and I want to make sure I get through chapter 10 before the end of the year. And we will do section 10.1, but we're going to start with section 10.2 because 10.2 is the law of sines, and then we'll go back. And 10.1 is the law of cosines. You guys did this in geometry, but since you guys had geometry last year and we were remote when we were doing this part, you may or may not remember it. So the law of sines, law of cosines, it's really not that hard. Tegan, is it really that hard? It's not too bad. Tegan's doing it in geometry right now. So we're going to do the law of sines first, and that's the deal. All right, so law of sines. We use, just to back up, we use SOHCAHTOA, SOHCAHTOA, was the sine, cosine, and tangent that we used, but this only worked for right triangles.
Oh, I remember.
This is only for right triangles, but what happens if you don't have a right triangle? That's when you use this stuff. You use the law of sines, and these are called oblique triangles. I call them non-right triangles, or you can call them oblique triangles. It doesn't matter. So if you don't have a right triangle and you're trying to find out what the sides are, or the angles are of a triangle, you use the law of sines, or the law of cosines, which is what we're going to do in section 10.1. Okay? Good? The law of sines. Here are two examples of some non-right triangles. This is an obtuse triangle. Obtuse. I'll zoom out. And what's the one on the right called?
Acute.
Acute, because all of his angles are cute, right? All of them are less than 90 degrees. Okay. Obtuse means one of the angles is bigger than 90 degrees. You can see that on angle C. So obtuse and acute, it doesn't matter which one you have, you can use the law of sines for these guys. Okay. You will know that you need to use the law of sines when you have two sides and two angles involved, one of which you are solving for. So maybe I have both of the angles and one of the sides that I'm solving for the other side, right? There's 4 pieces of information. 2 of them are sides, 2 of them are angles. One of them I'm solving for, okay? Let's go down to this example right here, okay? I have 2 angles. They are 31 and 20. Those are my 2 angles. And I have a side. It is 210. So I can solve another one of the sides really easily right now, and I will have 2 sides and 2 angles, right? Okay, we got to figure out which one we can solve first, though. So let's just write out, it says solve the triangle. So we're going to, I just write out ABC, ABC. Have we done this before? Yeah, when we did SOHCAHTOA. Okay, so ABC, ABC. We're going to write out all those guys, and we're going to write out what we have and what we need. And we don't even have the formula for the law of sines yet. What? I'm going to have to write that down. All right, so let's label some things. What is 31 degrees? Angle C, so put 31 degrees in angle C. Angle B is going to be 20 degrees. And what is 210? Side B. How do you know that?
Because everything else is...
It's opposite from angle B, so it is side B, okay? So there's that, and none of the other information we know, except we can find something really easily. What can we find really easy? Angle A, because these two added together are 51, and if I subtract that from 180, that gives me like 29 degrees is what angle A is. 129 degrees, okay? So we can solve that guy really easy, okay? Now, one thing that I want you to look at this right now. This is how you know you can use the law of sines. I have one side and one angle that matches it. Which side and angle do I have matching?
B's.
The B's. That's how I know I can use the law of sines, because I have the B's matching. Okay, ready? Here is the formula for the law of sines. Write it, I don't know, somewhere. Write it somewhere important so that you can see it. It is sine A over A equals sine B over B. The actual names of the angles are irrelevant. We don't care about them. Sine A over A, sine B over B, it could be sine C over C, just as long as the angle that you have up top here is opposite the side that you have here. So these angles and sides need to be over top of one another. Does that make sense? If it's angle A, it has to be side A below it. If it's angle B, it has to be side B below it. They have to match each other, yes. Okay? So what I always start with the law of sines by doing is I start with what I know. So I know the B's, right? So I want to do sine on the top. Sine of what?
129.
Nope.
What are you getting?
I do the ones that I know first.
Oh,
I do sine of 20 over what?
210.
210. And then do you want to solve A or C first?
A.
A, okay. So next on the right side we do sine of what?
129.
129 over
A. Or X.
C, or A, yeah, we call it A. Because we're doing A first. I thought we were doing C. A first, okay? Like that. And then what do we do? Now that I have this set up right here like this. We can cross multiply and divide, right? So I have this guy right here, okay? So check out the way that I write this out. 210 times sine of 129 is equal to A times sine of 20, right? And then I want to get A by itself. So divide by sine of 20. Divide by sine of 20. So really, you don't have to write it all out. If you can think about it in your head, you don't have to write it all out. A is equal to whatever 210 sine of 129 divided by sine of 20 is. Do you need to be in radians or degrees? Why degrees? Because you're doing sine of a degree, right? This is 20 degrees and 129 degrees, okay? So 210 sine 129 divided by sine 20, and A is something. 477.2.
I get that right.
That's huge. Are you sure that's right?
Yeah. That is right. Well, it's got to be bigger than B's.
Okay, yep, that's what I always look at. B is a really tiny angle, and A is a really big angle. So it has to be way, way, way bigger than side B, right? Way bigger.
It's over double.
It's over double, so yeah, there we go. Did you get it, MJ? You got it to where you didn't have the parentheses, right? Okay. Good? Good with that? What are you doing?
You do A squared plus B squared.
Just wait. I don't want to come over there because I'm recording. So just wait. Now for C, what did you say?
A squared plus B.
Now can we use A squared plus B squared equals C squared? Can we?
No,
Why not?
because it's not a right triangle.
It's not a right triangle, so we can't use A squared plus B squared equals C squared. Not a right triangle. So we got to do the same thing again. So I'm going to back up and I'm going to go to making reference to this guy here. I can set him up exactly the same. I can still do sine 20 over 210. But instead on the right side I'm going to put sine of 31 and C, right? So this same guy again, right? Yeah? Okay. And then all I have to do is take this guy, multiply those two together, and divide by sine 20, right? Okay. And I'm not going to write all that out because you guys kind of maybe get the idea. 210 sine of 31 divided by sine of 20, and that is what C is. 316.2. There we go. Okay. I think it wants all of the angles rounded to the nearest degree, but all of the sides rounded to the nearest one decimal place. Is what the usual thing is. Okay. Now, always check these 6. This is our answer right here. Whoop. These 6 elements here. Check to see. The biggest one, is it opposite the biggest side?
Yes.
The smallest one, is the opposite the smallest side? Then we're good to go. Okay. Probably correct. Yeah? Okay, now. We good?
No, I'm behind.
You're behind? Okay. Let me erase some of my little loopy things here because we got lots of stuff going on. Okay. I don't know.
Yes.
I don't even know if I finished my.
Okay. All right. Now, Tegan, you're going to be a little not a